Hi, this is a lesson found in your Grade 9 Pre-IB course pack, Section 2.6, Simplifying Polynomial Expressions. We're going to look at how we can use your knowledge from 2.4, Simplifying Polynomial Expressions by collecting like terms, and 2.5, Distributive Properties, to simplify more complex polynomials. Example 1, expand and simplify. So make sure even when you are working with polynomial expressions, the order of operations or bandmass still apply. So I have 2 times 3x plus 1 plus 5 times 2x minus 6. So first we multiply 2 by 3x, 6x, 2 by 1 is 2, plus you multiply again, 5 times 2x, 10x, 5 times negative 6, negative 30. And then you can collect some like terms. So 6x plus 10x, and then 2 minus 30 is negative 28. Collect like terms further, 6x plus 10x, that gives you 16x minus 28. B. You have a similar structure, even though this time you see some fractions. So remember, fractions are just numbers. So remember, if you have mixed fractions, it may be easier if you first change them into improper fractions. Like 2 and 1/2, you can write that as 5/2. And then you look at the order of operations again. You have 3 times a binomial minus 1/4 times another binomial. So use your distributive property to multiply first. 3 times 2/3x is 6/3x, or it can be reduced to 2/1x. 3 times negative 5/2 is negative 15/2. And then you have negative 1/4 times 2x. So you can see this as 2x/4 negative, or reduce this to 1/2x negative. And then you have negative 1/4 times negative 3. Negative times negative is positive, and you have 3/4. If you put the x terms side by side and the constant terms side by side, well, you notice that if you have 2/1x minus 1/2x, the common denominator will be 2. So your first term will turn into 4/2x minus 1/2x. And then the two constant terms with denominators 2 and 4 will require a common denominator of 4. So negative 15/2 will become negative 30/4. And then 3/4 stays the same. And now you're ready to use the rules for adding and subtracting fractions to collect like terms and simplify this polynomial. So 4/2x minus 1/2x is 3/2x. Negative 30/4 plus 3/4, that gives you negative 27/4. And this is simplified. Question C. I have 2a times 4a plus 5 minus 3a times 2a minus 7. So here, we start by multiplying 2a by 4a, that's 8a squared. 2a times 5, that's plus 10a. We have negative 3a times 2a, negative 6a squared. Negative 3a times negative 7, be careful with the sign, is positive 21a. Now collect like terms. I have 8a squared minus 6a squared. That gives us 2a squared. 10a plus 21a, that's 31a. And we have no more like terms, this polynomial has been simplified. D. Very similar structures. Multiply 3x squared by x squared using your exponent laws. Powers of the same base, when they're multiplied together, will require you to add the exponents together. So that gives you 3x to the power of 4. 3x squared times positive x. That's 3x to the power of 3. 2x cubed times x is 2x to the power of 4. 2x cubed times negative 4. Positive times negative is negative. 4 times 2 is 8. And then you have x cubed. I have two terms with x to the power of 4. So 3x to the power of 4 plus 2x to the power of 4, that's 5x to the power of 4, plus 3x cubed minus 8x cubed, that's minus 5x cubed. Example 2. A diagram is given. So here's a door with a triangular window. The dimensions are shown below. So the dimensions of the rectangular door are the length, 3x plus 2, and width is 10x. This is an isosceles triangle. So the height of this triangle is 4, and the base of this triangle is 2x minus 1. So first off, we're going to find the perimeter of the door shown, and we will only consider the outside border. So to calculate the perimeter, I need to add length and width together, and then times that by 2. So the formula is perimeter equals 2 times length plus width. So substituting length, 3x plus 2, and then you add the width 10x, you have 13x plus 2, and don't forget to multiply this by 2 for the 4 sides. So in total, you have 26x plus 4. To calculate the area of the shaded region, so the gray lines here, you can shade this in your notes. We will first need to know the area of the entire door, and then we need to cut out the triangle. So the area of the door is length times width, and then minus the cutout, which is base times height, divided by 2. So substituting 3x plus 2 for length and 10x for width, and minus 4 for the height of the triangle, and 2x minus 1 for the base of the triangle, divided by 2. We have this big chunk of polynomial, but just take your time to slowly expand carefully. You have 3x times 10x, 30x squared, plus 2 times 10x, plus 20x. And then you take away the area of the triangle. Notice how 4 times 2x minus 1 divided by 2 allows you to reduce the 2 and the 4 here. So essentially, you're going to subtract 2 times 2x minus 1. So here, we keep the first two terms because there's nothing else that we can do yet. And then we will first multiply or expand the second part of this equation. So I have, or expression, not equation, sorry. So here we have negative 2 times 2x, that's negative 4x. Negative 2 times negative 1, that gives you positive 2. And now the only like terms that you have are positive 20x and negative 4x. So 20 minus 4 is 16. And then writing all the terms in descending order, you have 30x squared plus 16x plus 2. Example 3. On average, the following number of adults and children pay to enter the fall fair. So here you're presented with a lot of information, and you're asked to determine an expression for the total entrance fees collected each hour after opening. So what we need to know then is the number of people who enter the fall fair at different times. So at 9 a.m., you can expect 20 adults and 25 children, and this is fixed for that particular hour. But in each hour after 9 a.m. until closing, you will expect 95 adults every hour and 120 children every hour. So that depends on time. And in order for us to calculate the total entrance fee, we also need to know charges. So it costs children $8 and adults $12 to go to the fall fair. So the total fare collected from children will be 8 times the number of children, and the total entrance fees collected from adults will be 12 multiplied by the number of adults. And notice how the fall fair is open from 9 a.m. to 10 p.m. So based on the table, we can start by looking at the number of children that comes into this fall fair. You start with the 25 children at 9 a.m. plus 120 times the number of hours. This is open after 9 a.m. And for number of adults, you start with a fixed number, 20, plus 95 times the number of hours. So if I want to calculate the total entrance fees, I'm going to multiply 8 by the number of children, which is 25 plus 120 each, and then add that to $12 times the number of adults, 20 plus 95 each. Expand using the distributive property and collect like terms. Since we know that the fall fair is only open between 9 a.m. to 10 p.m., there is a limitation on the values of age that can be used. So sometimes it's important to note what the limit is. Well, since it's from 9 to 10, so basically at 9 a.m. we can say that, it's 0 hours from opening, and 10 p.m. is 13 hours after 9 a.m. So that means age can take on values from 0 to 13. And sometimes we call this limitation on the independent variable the domain. You will learn more about this in the next couple of chapters. Lastly, example 4. Joy has change in a pocket consisting of nickels, dimes, and quarters. The number of quarters is twice the number of dimes, so we can represent this saying that Q is equal to 2D. Q is the number of quarters, D is the number of dimes. The number of dimes is twice the number of nickels, so D will be equal to 2N, or Q will be equal to 4N then. So to represent the number of coins in Joy's pocket, you will add N and D and Q, or N plus 2N plus 4N together, that's 6N. To represent the total value of the coins, you have to multiply the value of each coin by how many that you have. So 0.05 times N plus 0.1 times 2N for dimes plus 0.25 times 4N for quarters. And you're going to simplify this to 1.25N. So now if we have these expressions in terms of N, we can calculate how much money she'll have if she has 4 nickels. So you substitute 4 into N, and you have 1.25 times 4, that will give you 5. So in conclusion, Joy has $5 if she has 4 nickels in her pocket. So pause this video, rewatch it if you need more clarification. Save your questions and Ms. Kuhn will be back tomorrow to answer any of these. Now you can start working on your homework.